Hello, this is a quick overview of bearing and azimuths. This slight video will just go over everything I'm going to cover within this playlist. So, a quick overview of bearings and azimuths. They're both measures of directions, typically measured in degrees, minutes, and seconds. Bearings have the standard cardinal directions north, east, south, and west, while azimuths do not contain a cardinal direction. Azimuths range from 0 to 360 degrees, while bearings, as you can see, they range from 0 to 90 degrees. We're not going to have a 92 degrees northeast because it's going to pass the quadrant, the northeast quadrant. As you should know, bearings increase going away from the north-south line and they decrease going towards the north-south line, while azimuths, they increase going clockwise and decrease going counterclockwise. So anytime we're looking for a general direction, we want to put our crosshair at our start point. So for example, if we're going from A to B, put this little crosshair, the crosshair compass on point A's middle, and we see what direction we have to travel to get to B. As you can see, it's in the northwest section, so we're going to be traveling northwest. So anytime we draw our direction path, we have three main directions we go. We go north or south, and we can go east or west. And our third direction is a direct distance. So a quick method I have established is the hourglass rule. Anytime we begin at our start point of A, we always want to draw our distance traveled north or south first, and then we're going to draw our east or west lines. And then we draw the direct line. Doing this will create a partial hourglass, and this hourglass is going to help you with the math section of calculating bearings and distances. So for the hourglass rule, as you can see with these four triangles, each of these triangles create a part of the hourglass. All these bearings that are jumping off from this north-south line, right here, right here, right here, right here, will also be the interior angle of these triangles. If we keep your traverses constant with this hourglass rule, it makes work easier for you because your SOHCAHTOA rules are going to remain constant. And what I mean by that will be shown on the next slide. So for example, this triangle is going towards the northwest direction starting at A and going to B. We can always know that a change of eastings will be on the opposite side of this angle, while the changing of our northing will be on the adjacent side. Our direct distance traveled will be at the hypotenuse, very similar to this one. Adjacent will always be northing if you're doing the hourglass rule. The change of easting will always be on the opposite side. I'm going to cover SOHCAHTOA in a later session. It's just rules of finding the missing parts of a triangle. Converting through bearings and azimuths, you can just follow this quick little guide. You find out where your azimuth or bearing is at. Determine if we're given an azimuth or a bearing. Convert it based off its direction. If it's southeast, we follow this rule. If it's from 90 to 180 degrees as an azimuth, we follow this rule. 0 to 90 or anything in the northeast, follow this rule. Anything from 270 to 360, which is in the northwest section, we follow this rule of conversion. Anything southwest from 180 to 270, we follow this rule. This will give you constant values of converting bearings and azimuths. Okay, so flipping point A and the point B method. So essentially, if we start on point A and we want to find the directional to point B, that's fine. But what happens if we want to switch it? If we start on point B and we want to go to point A? Well, If we're working with bearings, we just have to flip the cardinal directions. Northeast becomes southwest, southwest becomes northeast, southeast northwest, northwest becomes southeast. So for example, from A to B, if we say that this has a bearing of northwest 30 degrees from A to B, B to A should have a bearing of 30 degrees southeast, because we're literally just switching these two cardinal directions. North becomes south, west becomes east. Now with azimuths, this requires slightly more thought. We know all of our answers should be between 0 to 360 degrees. So we essentially have to determine whether we should add or subtract 180 degrees. It's 180 degrees because a circle is 360 and a rotation is 360, a full rotation is 360 degrees, and we're doing half of a rotation, which is 180 degrees. So from A to B, it has an azimuth of 330 degrees. What we can do is we can subtract 180 degrees to get the azimuth from B to A, which is 150 degrees. So let's just talk about partial rotations. If we're standing on point B and we're looking at point A, we can say it has an azimuth of 315 in this direction. But if we're standing at point B and we're targeting point C, we know we have to travel at an azimuth of 112 degrees. So in order to determine the rotations, we're literally just finding the difference of an azimuth value. So from 315, if we're going from 315 and we have to figure out how to get to 112, we're going to go counterclockwise. So we can just do a standard subtraction. 315 minus 112, we're going to get 203. Now here's the thing, if we're going to rotate right past this north-south line, it becomes a little tricky. What we can do is, we can think of it like this. Let me change the camera method. There we go. So, let's let the camera focus for a second. If we're right here at 315 degrees and we have to connect to an azimuth of 112, something along this line, we know that this section is already 112, right? So what we have to do is find this small subsection and add it up. So we could say an azimuth of 315. Let's find the bearing value of that. A bearing value of 315, we can say 360 minus 315, we get 45. Then we can say 45 plus 112. We get 157. The easier way to do that is you can determine, there we go. We can determine that a full rotation is 360 degrees. If we know this partial rotation is 203, we can say 360 minus 203 and we'll get 157. Just keep in mind that this is a very bare bones lesson. I'm going to give each one of these topics its own video that you can study on within this playlist.